These are 12.3 day 4 notes. We're going to look at finding limits to infinity. But first, I want to do a tiny bit of review and just focus on what happens when we see a limit, we use direct substitution, and we end up getting a number over 0. So this indicates that we would have a vertical asymptote, and we can have one of 3 choices, one of 3 outcomes, I guess I should say. We would either have positive infinity, negative infinity, or does not exist as our answer. So graphically, if we were going to say it's going to infinity, that would be at that x value, we notice that from the right and left side, we're just going up forever. So then if we were looking graphically at negative infinity, it would be that from the right and left side, we're going down forever. And then does not exist would be something funky happening, like maybe we're going up to infinity, but also down to infinity from the right and left side. So obviously, if it's not approaching the same thing from the right and the left, we say does not exist. So when we're using direct substitution, a couple different things can happen with 0. So this is our 0 situation. We either have 0 over a number after we direct substitute, in which case our answer is 0, right? 0 over any number is 0. The second thing that could happen is after direct substitution, we get 0 over 0, and that's what we've been practicing recently. And this is when we say it's indeterminate form. So when this happens, we might need to factor or do something algebraically to eliminate that problem of getting 0 over 0. And then we also have a situation where after direct substitution, we get a number over 0, and that's what we were just looking at. We have one of 3 options when that happens. We either go infinity, negative infinity, or does not exist. And we need to usually look at the graph to help us figure out which option we're dealing with here. So now we're going to start looking at what happens when our x value is approaching infinity. And when you see the limit as x goes to infinity, you just want to be thinking, okay, the x values are getting really large. What's happening to the graph when my x value is just going to the right forever? We might also see the limit as x goes to negative infinity, which would be very similar. It's just we're thinking about the x values getting extremely small. So if we were looking at a graph, we're going to think about those x values that are going to the left forever. What would our function be approaching? So there's actually 3 ways to find our limits as x approaches infinity. We can do it graphically, we can do it algebraically, and then there's also a shortcut method, which is very similar to our rules with horizontal asymptotes, and that's what we're going to be focused on today. All right, so I jumped down to option 3, which is evaluating limits with the shortcut method. So as we're looking at our functions, we want to be looking at the numerator and the denominator and the coefficients that we have. And we want to be looking at the highest power and what the coefficients are for the highest power in the numerator and the denominator. So if the numerator has a degree that is smaller than the degree of the denominator, then the limit as x approaches infinity will be 0. So for example, the function may look something like this. So we have the limit as x approaches infinity, and maybe we have something like 3x cubed over 4x to the 5th. Okay, so in this situation, we have an x to the 3rd, x to the 5th. So the degree in the numerator is less than the degree in the denominator. So this is going to be a limit of 0. And what you can do is you can think of this as, okay, what's the highest coefficient here? It's the x to the 5th, right? So we have 0x to the 5ths in the top, and we have 4x to the fifths in the bottom. Well, anytime we have 0 over 4, our answer is 0. So that can be sort of a trick that you use to help you with this one. Now, second option, if the degree of the numerator is equal to the degree of the denominator, then we just use those coefficients, and that's going to be our answer. So this is kind of the nice one. So if we have limit as x goes to infinity, and maybe we have like 4x squared over 3x squared, right? So the highest degree for both the numerator and denominator is an x squared, so we just use the coefficients, so the limit would be 4/3. And then the last option we have is if the degree in the numerator is greater than the degree in the denominator. So this might be something like the limit as x approaches infinity, and maybe we have 5x to the fifth over 3x to the third. So the highest degree that we have is this x to the fifth, and it's in the numerator. So think of it this way. Your highest degree is x to the fifth. We have 5x to the fifth in the top. We have 0x to the fifth in the bottom. Here's a number over 0 situation with your coefficients. So this rule says that the limit does not exist, but I really want to make something clear. By definition, yes, the limit does not exist, but we are going to go a step further and figure out, is it going to infinity or negative infinity? So positive and negative infinity are special cases of does not exist. Okay, so yes, technically does not exist would be the limit, but we're going to go a step further and figure out if it's going to be positive infinity or negative infinity. Okay, and we'll usually do this by the graph. All right, so let's look at example 4. And your eyeballs want to be going to the highest power. That's what you want to be looking for. So the highest power we have is this x to the third. And I don't see an x to the third in the numerator. So I have 0x to the thirds in the numerator, but I have 7 of them in the denominator. So this is a situation where our coefficients, we have 0 over a number. So our limit is 0. Example number 5, I'm looking for the highest degree. It looks like I have an x cubed as the highest. So in the numerator, I have 2x to the thirds. And in the denominator, I have 0x to the thirds. So now I have a situation with my coefficients where I have a number over 0. So our answer is technically does not exist, but we're going to go a step further and figure out, is this positive infinity or negative infinity? Okay, so I popped over and I graphed this function, and you want to be thinking that your x's are approaching infinity. So your x values are getting extremely large. So we want to be seeing what's going on with the graph as our x values get bigger, the further we go to the right. It's pretty obvious that this graph is probably going up forever to positive infinity, but even if I zoom out a little bit, it's clear that this graph is just going to keep going to infinity. So that's one way that you can determine, okay, is it going to infinity or negative infinity? The other option is to play around with the idea of direct substitution. So if we were to substitute infinity, I know that seems kind of strange, but if we were substituting infinity, we'd have 2 to infinity to the third power plus 3 in the numerator. Infinity, being cubed, is going to be extra large, times 2, even larger, plus 3, even larger. So this is definitely a positive value in the numerator. In the denominator, if we think, okay, if I was gonna substitute infinity, I know it sounds strange, but we have the concept of infinity being squared. So that's even bigger of a number, times 7, plus 5. We're still staying super positive. So a positive over a positive, we are definitely dealing with a positive infinity as our answer. So whichever way you'd prefer, or if you want to go back and forth, you can do either. Look at the graph or kind of think of direct substitution, even though it's sort of a weird concept. All right, the next example, 6a. If you notice, 6a and 6b is the same function, but for 6a, we're looking as x approaches positive infinity, and then we're going to look at x approaching negative infinity. So let's look for our coefficients. So the highest degree I see is in the numerator. It's an x to the fourth. So I have negative 3x to the fourth in the numerator, and then I have 0x to the fourths in the denominator. So looking at our coefficients, we have a number over 0. So technically our answer does not exist, but we are going to go further and figure out if it's positive infinity or negative infinity. So remember, you can look at the graph. I'm going to show you the direct substitution again. So if I have negative 3 times infinity to the fourth power plus 5, let's think about this. All right, infinity to the fourth power, super large, but then I'm going to multiply by negative 3. So now that automatically becomes negative infinity. I'm adding 5, but I already have a really, really small negative number, so adding 5 is not going to make that positive. So I have a negative value on the top. And then in the bottom, I have 2 times infinity cubed minus infinity plus 7. Well, if I take infinity and I cube it, obviously that's a really big number. Times 2, still big. Minus 1 infinity, I'm still going to stay positive, right? And then plus 7, still staying positive. So a negative over a positive is negative. So this answer is going to be negative infinity. Remember, if you don't like that way, just look at the graph. Okay, so part B is the same situation, except we're going to negative infinity. So I'm going to show you the kind of direct substitution trick here again. So this time, I have negative 3, negative infinity to the fourth power plus 5. So a negative infinity to the fourth power is going to be a positive value. If I take a negative to the fourth power, it's going to be positive. But then I'm multiplying by a negative 3. So now my value just got really negative, and adding a plus 5 is not going to change that. So I have negative in the numerator. In the denominator, I have 2 times negative infinity to the third power minus infinity plus 7. So a negative value to the third power is going to stay negative. So I have a negative infinity times 2. Now I'm even more negative. Subtracting another infinity, more negative. Adding 7, not going to change me to positive with how negative we are right now. So this is a negative value over a negative value, which is going to be a positive infinity. And if you don't like the direct substitution method, here's the graph. I zoomed out pretty far. So as we're going to positive infinity, we're thinking about, okay, as my x values get really large, so I'm continuing to go to the right, what is the graph doing? It's pretty obvious that it is going down to negative infinity, and that was our answer. And then for part B, when we went to the left, so as x approaches negative infinity, we're thinking about this continuing to the left forever. What's the graph doing? Well, it's going up. So there's your positive infinity answer that we got.